Up. Well, thank you for inviting me to come. I've been here 5.5 years and feel like I'm finally settling in and still learning about more and more people and wonderful things at this place. I've been interested in this for over a decade, largely due to the influence of what I call my wise men, who are collaborators on this: Ian Zen, Ward Chesworth, Pete Palmer, and Paul Riton. We actually have a manuscript on this that's stuck in press for about the last 3 years, and I'm not sure it's ever going to get out. It's a Geological Society of America special paper on planetary catastrophes, and they meant to talk about big meteorite impact and big volcanic eruptions on the different planets, and I just got this wild idea of talking about human behavior as a planetary megadisaster, and so that's the roots of this talk, which has now been modified a number of times. So the bottom lines I want you to take home out of this are that natural megadisasters have happened in the past, and they've typically happened when the human population density globally has been very low. So it might have been high locally, but it hasn't been high on a planetary scale. And I'll talk about volcanoes and earthquakes as examples of these megadisasters to give you a feel for the time scale and the magnitude of geologic processes. And these natural megadisasters are going to happen again in the future because we can't prevent them. There's going to be a magnitude 10 earthquake or 9 earthquake somewhere and a big volcanic eruption. But their effects are going to be amplified compared to in the past by the high human population density. And then my final point is that humans ourselves are creating a new kind of megadisaster, which I've called a stealth megadisaster, and that these could put our civilizations into peril. And to just make the pronunciation a little easier for me, I'll slip back and forth between disaster and megadisaster. And just preface it by saying I'm not talking about the little things. I don't know how many of you are geologists, but I think not everybody. And I make a point that geology is what I call a bifocal science. We can look at things that are both near in space and near in time, or our discipline requires us to look at things that are way far away in space and way back in time. So we deal with timescales of billions of years routinely, and so we're trained in this concept of deep time. And we also tend to travel a lot. My first trip out of the United States was landing in Calcutta at midnight and going across India by train and truck. You see a lot when you live a life like that compared to the way I was brought up, which was in a 60-mile radius of my hometown in northwestern Pennsylvania. And in geology, we're taught that the fundamental, page 1 principle is the principle of uniformitarianism, which is that the present is the key to the past. And people often assume that means that everything we see in the present is like the past was, but it's not really meant that way. The present's really the key to the past. And in one important respect, the present isn't like the past and not the key to the past, and that's in the heavy population that we've got globally now. There simply aren't any frontiers left. And so this has given rise to the idea of spaceship Earth or island Earth. And I use this a lot. Jared Diamond has used it. A number of us do in the context of finite resources. And you can get into debates whether it's a good analogy or not, but I'm going to make the assumption that right now it is a good analogy. And if not a good analogy, we at least ought to be able to look at the question of whether island societies have ever been successful and sustainable in the past. And as far as I know, only 2 examples have been shown. And the first one, this little island of Tikopia, is a little island in Polynesia that's so small it's probably not a great lesson. The second second sustainable society is one that Bruce Hannon in the geography department here has worked on and published on, and that was the Tokugawa regime for a couple hundred years in Japan. And what we've learned by looking at these are pretty eye-opening lessons. Mangaia is an island in Polynesia that's actually bigger than Tikopia. And Mangaia went through, and this was a couple thousand years ago, that's hard to look at. It went through unchecked population growth, a drastic reduction of forest cover and biodiversity as people attempted to use the forest to survive. That caused soil erosion. That increased the fire regimes, and this destruction of the ecosystem and the forest caused the soil, which is a laterite, to turn into brick. And so this destabilized the biosystem, and it produced constraints that limited the cultural responses. And as a result, it became a pretty brutal society with ritual sacrifice, mutilation of enemies, cannibalism, and rule by force and terror. And those of you who are familiar with the more popular Easter Island, because the archaeology is better, would recognize that story. Now, on Tikopia, there's not a whole lot of archaeology available on this, but I was desperate for success stories. And Tikopia, for about 1,000 years, followed the course of Mangaia, but it actually is a little bitter geologic setting. The soil's somewhat richer, and so it was more resilient. And these people then developed new strategies for agriculture in which they used both levels of the forest canopy. So they didn't destroy and slash and burn the forest. They learned to use the forest sustainably. They also strictly regulated population by infanticide, celibacy, abortion, sea voyaging, and expulsion to neighboring islands. And actually, to this day, that's the way they control and the society here. So it's a pretty brutal regime. Now, it's probably possible because the total size of this island is less than 5 square kilometers. So that's a pretty sobering realization. And if you look at the Tokugawa society in Japan, which was the ruling shoguns until Admiral Perry decreed that Japan would be open, they managed to be a self-sustaining society for a couple hundred years. And that society arose out of a brutal history of warfare when the biggest shoguns finally got enough control they could say there will be peace. And they enforced it with a horrendous set of levies and population control, probably including infanticide, and killing of foreigners who came to the soil. They did not want that island open in order to make it sustainable. So if you think about coming to a sustainable society and think of these kind of possible policy, well, that's a hard one, issues, you're looking at some pretty serious decisions. Well, the driving force for stealth disasters that I'm going to talk about later is population growth. And if you just look at any typical population growth, this one's the Western Hemisphere from the Old Stone Age for 500,000 years up, you see this tremendous increase in the absolute number of people on the planet. And we've been escaping facing any limitations by simply having frontiers that we could go back and populate. Well, Malthus, in 1798 and later editions, noticed, of course, this proposed this idea that there were finite resources and exponentially increasing population, and therefore there would be a crash. And in fact, we haven't seen a crash globally. We still have an increasing food production per capita. We have seen it crash probably in Africa. And so we want to look at how have we avoided the Malthusian scenarios. Well, here's my definition, and this actually is unique to our group. We've come up with this term stealth disasters. So what we call natural disasters are natural, but they can be amplified by human behavior. So these are things like earthquakes, volcanic eruptions, fires. There's some things I'm not going to talk about, but these are planet Earth processes. They typically have a sudden onset, like an earthquake, boom, and immediate consequences. There are historic examples. The present is the key to the past. We may only experience little earthquakes here in New Madrid. We have a historic record of a big earthquake. In other places, we have geologic records of big earthquakes that were pre-human. And from these natural disasters, remediation and recovery is typically possible. On the other hand, what I've defined as stealth disasters are caused by humans, but they do involve the natural systems around us. And some examples would be soil erosion, water contamination, climate alteration. And these often have a gradual onset, so they're kind of sneaking up on us, and this is where the word stealth came into our minds. But they will have near-term consequences, so it's not that they're sneaking up and we're never going to see the consequences. And they're new to human experience at the global scale. We can look at those island societies and say, yeah, we can see those disasters in island societies, but we haven't had the perspective to look at them on global scale. And remediation and recovery may actually be in question if you lead to collapse. We could conceivably lose all the soils in the world, and it takes a long time to longer than the development of civilization to regenerate a soil. I'm not going to discuss some of the fun exogenous events. There's always the chance of nuclear warfare, bioterrorism. Nanotechnology gone wild is a fun one with the science fiction. There's the possibility of a volcanic intrusion into a nuclear waste repository, and I worked on that at Yucca Mountain a little bit. And then Posner, which I think is the author of this book, he's a judge actually, but he suggested that a high-energy physics experiment might go awry. And I made the mistake of giving this seminar in physics one day, which they were trying to pin me down on which one. Anyway, natural things we know can happen are solar outbursts of charged particles, supernova explosions, big meteorite impacts of the scale that wiped out the dinosaurs 65 million years ago, or magnetic field reversals. So I'm going to call those giga disasters and not deal with them because there's just nothing we can do about those. So I'm going to talk first about natural disasters to give you a feeling for the frequency of these big events. I'll use volcanoes and earthquakes. Then I'll talk about some stealth disasters, and then some concepts of our limits to our Earth resources and some ideas I've had about sustainability. So what is a natural mega disaster? Well, to get your intuition in, I've worked both on geyser eruptions up here in Yellowstone, and I worked at Mount St. Helens. So Mount St. Helens is down here. It erupted a few tenths of a cubic kilometers of magma. And these cubes just show the relative size of magma volumes that have been erupted on different places on these different time scales. So we have the ones you've heard of down here, Mount St. Helens, Pinatubo, Krakatoa, Crater Lake, probably some of you have been there 7,000 years ago, 75 cubic kilometers of magma. Then Tambora eruption in 1815. Then these three Yellowstone eruptions that go back sort of at 500,000 year periods to 2 million years with up to 2,500 cubic kilometers of magma. So we're talking about something that's 10,000 times the size of Mount St. Helens. We're talking about having an event that's the size of Yellowstone National Park, basically. So we haven't seen mega eruptions in human history, but we've seen some pretty big ones. Oops, got too many controls. Well, globally, ash falls devastate very large regions on scales of every 10 to 500,000 years. This is my colleague Grant Hyken's slide. And we see the little volcanoes down here, this is one I actually have a friend studying. 1 cubic kilometer of magma erupted from a geothermal bore in Iceland where the magma happened to come in and tear a bore well apart and oozed up through the top, and I've actually seen it. You can go there and look at it, and that's the smallest known extrusion. Whoops. Then every few weeks we've got these little guys here. We've got Kilauea, Mount Unzen, the Japanese, up near Alaska. We've got these things that go on weeks. We've got the St. Helens type eruptions that are every sort of 10 years somewhere around the world. Pinatubo once every 10 to 100 years, Krakatoa maybe every 1,000 years, although there's a really interesting work that suggests Krakatoa-type eruptions might be a little more frequent than we realized. That's just coming out. And then Yellowstone and Toba up here. So these are, I like to, when I'm thinking about sustainability issues, I like to think about things that can happen to civilization on a time scale of about 100 to 1,000 to 10,000 years. I mean, 100 years we kind of live with. 10,000 years we don't really have a clue. And the criteria for safety at Yucca Mountain is basically that it's permanent, both here and in Canada, it's permanent nuclear storage for 10,000 years. And any event that has a probability greater than 1 in a million of occurring has to be examined very carefully for those repositories. And the reason I was called in to consult on the Yucca Mountain issue was that the probability of a magma injection into the repository at Yucca Mountain is slightly greater than 1 in a million, and so they had to study it. Well, the effects of volcanic eruptions on plants and animals range from complete burial by ash, where the plants die, to heavy plant damage. If you have heavy plant damage, your pollinating insects will die. Your food supply gets destroyed for the grazers and browsers by tooth abrasion and fluorine poisoning, and the recovery depends on climate. And you can have mud flows and lahars, which are volcanic mud flows, for years to decades. And right now, the big problem in the Philippines is that they've got, and in Indonesia, is they have a lot of active volcanoes that are active on the timescale of decades, to even centuries, but they have the monsoons that go through, and so they just have mud flows after mud flows for forever, basically. And we're actually seeing some migration. Some of the immigration and migrations of people from Central America are because of the devastation that the volcanoes are doing down there. Well, in Iceland in 1783, there was a fairly benign eruption. It was just long. It was a fissure that opened, and magma just sort of kept bubbling up and making these really nice curtains of fire. But it put out an incredible amount of sulfur dioxide. And this eruption resulted in a 5-degree cooling in Europe. Benjamin Franklin had just invented the thermometer. He recorded cooling in the northeastern U.S. during this eruption. And there was a loss of livestock in Iceland, and 25% of the population died from this eruption. And they're starting to realize the effects in Europe were bigger than they had realized. In Krakatoa in 1883, the eruption heard around the world. There was an eruption of 25 cubic kilometers of magma and 36,000 deaths. And further away from volcanoes, what would I say? Well, there's the climate and weather change. I guess the only point of this slide I wanted to do is that some of these really big volcanic eruptions that we haven't even documented yet may be responsible for some of the oral traditions in ancient times, some of the Bronze Age myths and time of darkness. And Grant Hyken has documented some of this. Now, I want to mention the Toba eruption 73,000 years ago. This was 2,800 cubic kilometers of ash. And the thing that's really interesting is that apparently sometime between Toba and Krakatoa, the strait across Java and Sumatra here was actually one continuous piece of land. And there's a proposal now that a proto-Krakatoa may have created that strait, and that there was something that went on before this relatively smaller Krakatoa. So anyway, 73,000 years ago, Toba erupted, and Stanley Ambrose on campus has studied this and proposed that there was a climatic bottleneck. And you can see here that Toba is a big eruption. It's the same size as the Yellowstone ones. And Ambrose's ideas are that there was 6 years of extremely cold volcanic winter that precipitated a 1,500-year instant ice age, and that in turn caused what he's called a genetic bottleneck. And his proposal is that at 71,000 years, the human gene pool may have gone down to as few as 100 to a few thousand females, and that we have then erupted from this bottleneck as the descendants of relatively few people. I can't speak to the biology of it, but I think it's a fascinating idea. So somewhere between this Krakatoa and the Toba and Yellowstone, we have to distinguish between mega-scale eruptions and gigascale, and we have to do that for earthquakes too. And there are some things we can engineer for and other things we can't. So I just want to bring out a few statistics on earthquakes. I have found, to my amazement, as I've gone through some of these things I didn't hear about or didn't remember. For example, I was alive and an adult in 1976. And I didn't realize there was an earthquake in China with 250 to 600,000 people killed. In 1566, there may have been 830,000 people killed in an earthquake. And repeatedly in Iran, Syria, Japan, Turkmenistan, Italy, Pakistan, Peru, Portugal, they have earthquakes that kill on the order of 100,000 people. So these are big events. They're ongoing. The consequences often depend on the engineering capabilities in many parts of the world. I'm going to show you one last earthquake, one that's a little bit scary to think about. One of the places where we can look and say that the effects of a future mega earthquake will be different than the past is up on the Seattle, Vancouver, British Columbia fault. I think it's called the Cascadia Fault. There was probably a magnitude 9 earthquake on that in about 1680 to 1720 AD. There's been a lot of research doing trenches, plus reports of tsunamis in Japan and around the Pacific at those times. Well, we don't know the population there. They found a few charcoal pits, but it was small. And today there's 3 million people living on the areas exposed to the consequences of this, and tsunamis could be up to 35 feet in height. San Francisco had a magnitude 7.7 earthquake in 1906. That's not a terribly big earthquake for the San Andreas. and 700 to 3,000 people died out of 400,000. And today the population there is 7 million. So it's just a different sociologic setting. And the place that I've sworn I'll never go, but I probably will end up going, is Istanbul. This has a really unique kind of earthquake pattern called earthquake storms. And it's a type of fault that every few centuries has a few big, whopping big earthquakes and then is quiet. And the Anatolian fault, which comes up through here, is unzipping right toward Istanbul. And the current population in that area is over 300 million. It's projected to be 400 million by 2015, of which 10 million are in Istanbul. And the U.S. Geological Survey has projected that there's a 60% chance of a magnitude 7 or 8 earthquake by 2030. So you're looking at a massive fault in a massively populated area. So the bottom lines from this part of the talk are that we live on a planet that has constantly changing geologic conditions. Some of the changes are gradual, some are catastrophic, and the impacts on us and our civilization are going to be much larger in the future than in the past because of the number of people and the interconnectedness. An earthquake in Indonesia affects us in North America in ways that it never did before the global economy developed. I was actually wondering at one point how this China snowstorm that was going on a week ago was going to affect our economy, since so many things had. Okay, stealth disasters. And the two things I'm going to dwell on here are rivers and soils. There's also fresh water, there's the ecosystems, any number of things. I think I list a number of them at the end. So I've defined, I'll just review, stealth disasters as being caused by humans but involving the natural systems that support us, having a gradual onset but near-term consequences, and being new to human experience on a global scale. And remediation and recovery possibly being in question, leading to a collapse of the civilization. So the bottom line 3 is that human behavior is causing these stealth disasters. And I actually had this slide made up before I was invited to speak here, but I thought for this Waste Management Research Center it was a very appropriate slide. I don't know if you deal with light pollution, but so one of the things we can learn about human behavior and natural systems is our effect on large river systems. We have here with the Mississippi River maybe 125 years of manipulation. On the Nile, they have documented 7,000 years of significant human manipulation. And as far as I've been able to see, all of the things that we've learned from the dams on the Colorado River, which go back to the early part of the century, the messages were there in the early Egyptians' manipulation of the Nile. The history of the Nile is, let's see if I can locate the relevant places. Somewhere there it actually shows the Aswan dams because we found it before. I think the Aswan dams that they built with the Russians are here, and Cairo's down there. So the population in Old Egypt was concentrated in Memphis and Thebes, and there are historical reports that by 2200 BC, limits on the resources of the Nile may have actually caused the decline of the Old Kingdom. The Aswan dams were put in between the 1889 to 1970, and they now affect a population of over 60 million people. Cairo is one of the most densely populated cities on Earth, and it's on the delta of the now manipulated Nile. Well, some of the lessons you learn by looking at human manipulation of rivers, and I have whole lectures I could give on this, but generally the loss of soil downstream of a dam, because it's all deposited upstream, means that you need fertilizers. And when you use fertilizers, you concentrate toxic elements into the soil. So downstream of the Aswan dams, there's a huge poisoning of the soils by the use of fertilizers. The stagnant water that occurs downstream of these places leads to the reemergence of diseases, of which I think schistosomiasis is one in the Nile. It's not a very pleasant disease that snails carry. In the case of the Nile, the loss of silt and algae has caused a decline of the sardine and shrimp resources in the Mediterranean, And the loss of fresh water into the Mediterranean is allowing the Red Sea fauna in the Mediterranean to go across the Suez Canal. And so we see upstream effects behind the dam as well, such as sedimentation, tremendous cultural dislocations. The Three Gorges Dam in China is the big, currently controversial mega dam. And you see ecosystem changes around the whole dam system. So these river systems are broadly coupled into the hydrological cycle and climate, and I just wanted to bring in here that we have the feedback where we have global warming affecting the hydrologic cycle and the hydrologic cycle affecting the global warming. We as humans are changing the surface of the Earth, which is changing the climate, through the ozone hole and through the changes of the albedo, both in our cities and in the polar regions. And we're affecting the rate of CO2 accumulation in the atmosphere and therefore the rate of temperature changes. So I want to leave that as one sort of mega field that we're operating in and switch over to soil because it's relevant to here. Soil is subject to compaction and erosion, and this has been caused by plowing, overgrazing, compaction by heavy machinery, acidification, use of fertilizers, and just plain wind erosion. There's a big problem with wind erosion in northern China right now in the soils. Human-caused, it's been controversial but increasingly documented for the last 10 years that human-caused soil erosion now exceeds that caused by all the rivers in the world by 3 to 10 times. We are just tremendous earth movers. And our agriculture is causing a lot of that soil movement. And soil is not a renewable resource on timescales related to the stability of human civilization. We're focusing on Illinois geology in a sustainability class I'm teaching, and Bruce Hannon was talking yesterday about how the original settlers were in very southern Illinois, and within a very short time of settling there, they lost the whole A horizon of the soil by bad soil practices. And that just doesn't regenerate quickly. So soil, I just put up this slide of plate tectonic processes. Soil is created by geologic processes, and it's going to be regenerated on geologic timescales, typically thousands of years or longer. An example of the loss of soil I like to point out, because a friend of mine discovered it and documented it, was the deforestation of southwest China karst topography under Chairman Mao. And Peter Huntoon went in there in, I think, the 1990s at the invitation of his colleagues to look at something else. And he was walking around, it's in these 3 provinces, which are in southwestern China. And said he was walking around and looking at the scenery and realized that he should have been in a jungle and there wasn't a tree around. And he started asking what happened. Well, the topography here is underlain by karst, which is a limestone that weathers. And in the U.S., we talk about karst making caves, and we emphasize the negative relief we get from the topography. But the Chinese actually call these stone forests, and they emphasize the pillars that are produced, and that's what produces this famous topography in China. There are 3 million square kilometers of carbonate rocks in China. It's 31% of the land area of the country. 900,000 square kilometers are in tropical and subtropical humid climate zones, which means they tend to get these really bad soils. 95% of the 1.2 billion Chinese lived in the eastern half of the country in 1992. 100 million of these, including the ethnic minorities, live in the South China karst belt. And the ethnic minorities are not a well-treated people in China, and they certainly weren't under Chairman Mao, who came from one of these areas. They are still amongst the poorest people in the country. And the poverty largely is due to the severe annual flood drought cycle that was exacerbated by what happened in 1958 onward. And what happened was that Chairman Mao came in and set the goal to build a modern infrastructure in China, which required steel and cement. And to do that, he had to have wood for fuel. And so he ordered a horrendous slash and burn of the wood in the forest with quotas that were amazing. I mean, these people had to dig the stumps out of the ground to get the wood to fill the quotas. And the total extent is still unknown, but it was at least these 3 provinces that were required to produce more than 3,000 cubic meters of wood a day. Well, they sort of got out of that phase, but then phase 2 of this, and what happened was they took off the wood, which affected the soil, which affected the groundwater. And to jump ahead in the history, the Cultural Revolution came from 66 to 76, and there was anarchy, so the peasants were using the forest in an unchecked way. So one of the bottom lines of sustainability is you've got to have political stability. So any attempts that have been made to replant this forest have met with failure because of the historic events in China. And the third phase, starting in 1979, was the decollectivization of the communes, and when the peasants dispersed into the countryside, they then used the forest to rebuild their new facilities. So to this day, it's a very poor and barren place. And so what happened was that they lost the so-called green reservoir. And the groundwater that was previously stored in the forested hills was then gone, and that exacerbated the flood drought cycle, which caused them to have drier and hotter seasons and therefore desertification. And when Peter gives this talk, it's really pathetic, because for me as a woman, because the women are nothing but beasts of burden. They walk tens of miles a day carrying water from these dried up wells or little twigs of firewood. I mean, and they go up, and it's just horror stories. They'll go up and try to get coal that falls off the cars and the trains. It's a very large, bad region. So moving on from the deforestation to the agriculture, I'd just like to stress that agriculture is a geologic process in scale. It moves a lot of cycles. It moves a lot of soil, and this soil movement is affecting the rivers and the oceans globally. Chemical elements are being removed from the natural system at 1 to 2 orders of magnitude faster than the weathering can replace them. And with the addition of fertilizer, we're modifying the planetary geochemical cycle. Agriculture, according to Ward Chesworth, uses 70% of the world's available fresh water. So I guess on this side, I guess I do need to point out, whole biomes have been taken over by agriculture and their soils, because the next slide I'm going to show the amount of soil that's considered heavily degraded in the world. And our current agricultural practice depends heavily on the cheap energy of fossil fuels since World War II. We have a massive dependence on fertilizers. I think here we're all hearing the farmers talking about choosing what they're going to plant next year because the cost of fertilizer is going up so high. And it puts a great stress on the biosphere from the waste products. The nitrate contamination of a third of the groundwater resources in southern Ontario is significant. And here with the Mississippi, we have the anoxic zone without any oxygen down in the Gulf of Mexico. Well, this is a map of soil degradation, and a lot of these places where the soil's degraded used to be temperate forests that were taken over and changed into agricultural area. But the yellow and red areas are areas that are considered very degraded soil. Well, how have we avoided the Malthusian disaster? And you can look at this, whether it's in importing fuels into the U.S., a number of ways you can look at it. But the bottom line is that without some sort of technologic invention that has allowed us to stave off, if not avoid this disaster, we were kind of very slowly producing a Malthusian kind of resource. And then we invented this energy-intensive technologies around World War II, and we've been staving off the Malthusian disaster by having this additional energy input into our production of food. They haven't been able to do that in Africa. So I'd like to say that soils are just one of a number of stealth disasters challenging us. There's soil quality and stability, there's fresh water quality and quantity, climate change, both atmosphere and ocean effects, biodiversity, population, the ability of the planet to absorb waste. And I'm not sure if I made this up or I heard Jared Diamond say it, so I have to give him credit. We have to solve all of these problems simultaneously, because missing any one of them might lead to collapse, and that's a pretty intimidating prospect. So here's a take-home message. I asked one of my colleagues if I should write this up for a letter for the News Gazette, and he said, no, people don't like to hear bad news. If you take an exponential growth curve, we have 6 billion people on the planet now. The best population projections are that we're going to stabilize around 9 billion in 2050. Well, suppose that a mega disaster happens in 2050, which causes system collapse, and the reduction population has to go back to a level of 3 billion. And I'll tell you, this conclusion doesn't change if you want to pick 1 billion or 5 billion. It's a pretty daunting conclusion. And let's suppose this mega disaster plays out for 60 years after 2050. So it's a plague, or, it's kind of one of these creepy sort of events. You will have 250,000 deaths a day more than you will have births to get back to that 3 billion people. And I have done this calculation over and over. I beg anybody to check and see if I've missed decimal places. But that's the same loss as the Sumatran earthquake every day for 60 years. And just the thought of how you bury that many people is pretty intimidating. So this has not been published in the News Gazette. Okay. Let's look at what sustainable means. You can go out there and get yourself really mired down in this. But bottom line is, it means a system that lasts. It's a sustainable system. And you can pick your own time scale. Pick 100 years so your grandchildren have a kick at the can, or 1,000 years, or 10,000 years. What really matters is that we're embedded in a finite planet. It's a finite biosphere, and there are limits to growth. Matter's conserved. You can't get something out of nothing. Waste doesn't become nothing. We conserve. And I didn't put this in for this talk. It's just part of the whole picture. Energy is conserved. Usable energy is gradually dissipated into an unusable form. And we're just stuck with these laws of physics and math. It's the way the natural world runs. Well, I'm teaching a course this semester it's called Planet Earth's Challenges to Sustainability. And the text we're using is by Kaufman and Cleveland. It just came out this year. We changed our whole course on day one because we discovered this text. And Cleveland was a student here of Bruce Hannon's. And it's a book based on science, but it has the economics, it has the policy, it has the ecology. I mean, there's so many things you have to be able to cover. None of us who are in this effort think we can cover all of this. But in chapter 1, this book, they start by saying, here's 4 principles of sustainability. 1, a sustainable society does not use natural resources or produce waste faster than they are regenerated or assimilated by the environment. 2, sustainable societies must avoid actions that trigger feedback loops that amplify disturbances. We don't want to hit the trigger point, or whatever it's being called, in climate change. We don't want to hit the trigger point that caused the Aral Sea to dry up. These 2 principles, which as scientists we're sort of used to, they have to be meshed with ethical and moral principles of fairness, both to the present generation and the inequities in the world and future generations. We can't discount the future completely, or as much as is being done. And the 4th line is social incentives must reward those who act in a sustainable way and punish those who act in a non-sustainable manner. And I don't know how many of you have heard of David Suzuki, Canadian environmental scientist. Last week he called all politicians who ignore science to be put in jail. And that goes with this 4th principle. So principles 1 and 2 imply that radical and difficult reforms are needed. And I'm getting into speculation. Remember, I'm a geologist, but it's kind of where our group has come from. We feel you need to reduce the ecological footprint. And you need to bring the economies of the world into a new kind of economics that deals with finite resources. It's been very interesting from this perspective to watch the patches that are being proposed for the American economy. It's consumerism, more growth. And if you start thinking along the lines that we've been thinking in sustainability, that's not a viable economic model. And so by saying that a new economic model is needed, it's a paradigm for saying that a new policy is needed. This is a slide to show, just illustrate principle 3, the inequities. It's the ecological footprint per person in units you don't need to worry about, basically plotted against the Human Development Index, which is a measure of education, food, and health, I think. And you've got countries like the U.S. here, Kuwait, United Arab Emirates, Australia, Sweden, Norway. You've got Central Africa down here. Got Bangladesh, Vietnam, South Korea, Italy, Japan. So you've got these circles of countries that are pretty clearly unsustainable, countries here that may be unsustainable because they're so poor, and then countries in the middle, but great ranges in equity and living conditions that probably mean an unsustainable global thing. So some of the things we feel you have to do are break the collective denial. Doing nothing is not acceptable. Admit to the magnitude of the task and remediate and adapt where possible. Get to work as a global endeavor, invoking all aspects of human civilization. In the face of uncertainties, let the scientific process go forward, including the uncertainties, but try to act wisely and prudently. And then something that I think many of us are concerned about is to make sure the actions are real and not delusions of action. So calls for global action are actually not old, but they're not new. One of the oldest is Aldo Leopold's Land Ethic. The World Scientist's Warning to Humanity was in 1992, and I was a co-signer on that along with about 1,700 other scientists listing 4 or 5 major problems and possible remediation. Current people you might have heard of, Thomas Homer Dixon is a Canadian political scientist. Jane Lubchenco is an ecologist who's written this book, this article in Science on Entering the Century of the Environment. Pete Palmer is one of the wise men on this presentation, and then David Suzuki with his proposal to put the people who ignored science in jail. I've been thinking more on the level of global actions, and we tried to find global templates. The United Nations, turned out, is not well mandated to deal with sustainability issues because it really grew out of the need to control arms after the war. And if you look at the mandates of the UN, they're biased by that founding. But what we proposed is that you may need 4 types of bodies. A scientific body, such as the surveys here, to provide impartial facts and uncertainties. The Millennium Ecosystem Assessment, the IPCC, or the ecological footprint efforts are perhaps science in that vein. An engineering body to propose and implement technical solutions, and I think maybe the Waste Management Research Center here could be in that category of globally needed bodies. And a very large voice for this is Gus Speth, who's the Dean of Forestry at Yale. A negotiating body to do the political, economic, religious, and cultural work. The United Nations does have a global environmental program. Don Kennedy and Paul Ehrlich proposed a Millennium Assessment of Human Behavior in 2005, but I followed up with them, and apparently nothing's happened with that. And then some sort of enforcement body that's responsive to all of the bodies. And this is maybe coming back to the Tokugawa regime or these little islands. The enforcement could be pretty brutal if we don't think this through. And I'm actually a dual citizen with Canada, and I've always liked the idea that Canadians have peacekeeping forces instead of armies. So maybe the Canadian peacekeeping forces are a model of enforcement agents. Like I said, I'm speculating here. And so I wanted to close by describing a project that we have going on in my class with Bruce Hannon that's going to be fascinating. The students seem really into it, and that's to design a path toward a sustainable Champaign County. And this capitalizes on a project that Bruce had a group of honor students do about 15 years ago, in which they pretended they were settlers leaving St. Louis in 1820, and they were settling Champaign County, which he called Solitaire County. And they had to design Solitaire County. And it started with having to design even how many settlers would leave St. Louis, because they had to figure out what genetically diverse gene pool they needed to go forward. And the one rule they put on Solitaire County was that there couldn't be any immigration, because they couldn't control the problem if you allowed immigration. Of course, today the students look at it and say, look, we've got to be realistic. So we're just getting to the point of organizing this. It's been a real interesting endeavor to start, because I've had enough experience teaching this to know that the students, you can get stuck in dead ends. It's really easy to suggest recycling paper and doing things, but to really tackle this. And one of the sobering things was that the Solitaire County concluded that the stable, sustainable population for Champaign County was 20,000 people. So yesterday's discussion was, oops, where do we start? And we told them it's not so important that they have the right answer at the end. It's the process that we're going to go through of designing this exercise and thinking through a path, because we think that some sort of change is inevitable, and really the choices we're being faced with are how we get there. Do we go through the conflict and chaos of the early Tokugawa regimes and the chaos? I mean, that's one option, is that things are just going to get really chaotic globally. I found a document this thick the other day that documented wars over water back to 4000 BC. And so the question for the class then is going to be, how can we get toward a sustainable Champaign County? So I guess I'm open to questions. I thank you for your attention. Yeah.
Do you feel that humans are going to be able to avert these stealth disasters, or do you actually expect them to happen?
To avert what?
The stealth disasters.
I think they're there, but part of the definition of a stealth disaster, and I think I had on the slides, is unlike a natural disaster, we have the ability to control our own behavior. So whether we avert it or not, to what degree we avert it, it's going to depend to what degree we can modify our own behavior. So I think it's under, at least at the moment, is potentially under our control. If we go over a threshold like Lovelock is projecting for climate change, then it's beyond our control. Yep.
Do you have any feeling on the wisdom of urbanization in relation to what you've been saying? Like, we have basically 4 cities in the United States. We've got Los Angeles area, Chicago, northern Indiana, the New York area, a few others, and then we've got 2 little towns beyond that. Is concentrating the people like they're doing around the world a good idea? Bad idea?
It's a lot. It has been a bad idea. And I just finished reading a book called The City of Joy, which is about, that's a name of a slum in Calcutta. And the people go to the slum, have gone to the slums in Calcutta historically when the land has failed them. And then they get in there and have no way to make a living. Plus, typically when they go into the slums, they take with them the practice of having big families that worked out in the land, but didn't work in the big cities. And so, in that sense, not much about urbanization has been good. It's a little bit like a question about megadams. Do you take out Glen Canyon Dam or not? I mean, can you go backwards from big cities? I don't think I'd like to say whether they're good or bad, but if you want to read something very sobering, type in the long emergency on Google, and you'll get the website of the guy that wrote this, and you'll avoid reading his book, which is about 5 times too long. And he talks about America post-World War II, cheap oils, and the freeway system, and how he thinks America's, your regions, how he thinks it's going to change after the Hubbard peak of oil production. And it's not actually after, it's during. And so he divides it, and I can't remember his conclusions, but it is that cities are bad because, let's see, he thinks the Southwest is just going to disintegrate because of water. The Chicago Midwest is the infrastructure will disintegrate because the big skyscrapers and modern infrastructure can't stand several years in a row of loss of facilities due to storms and disruptions. So it'll kind of disintegrate. The Bible Belt disappears into religious strife under the stress. I forget what happens to the Southwest and the Northeast, and he has the Northwest getting taken over by Japan or China. I forget. It's a wild book. That's why I'm saying read the website. But the guy's a very, very respected writer for the Atlantic Monthly, and I found the book very thought-provoking. And one thing he does is contrast the U.S. versus Europe post-World War II, where we developed the interstate transport system and we conquered our big distances and urbanized them. Europe kept their villages. And that's a big difference. And he thinks Europe's going to be a much more stable society as we go through this because of that lack of big cities. But it's a very thought-provoking article, whether you agree with it or not. Yeah, Val?
If you disseminate people from the cities, they don't know agriculture from squat, and they don't know anything about hunter-gathering. They don't know how to reduce their consumption rate, and so in the current modern mindset people we have, to me, the efficient way is urbanization in terms of, human footprint. People aren't traveling so much, they're living in high rises, they're not consuming so much energy per dwelling and all of that. So isn't there a necessity of continued urbanization, perhaps enhanced urbanization, until the population starts to go down, and in the context of that, trying to come up with a more rational scheme for agriculture to make it more sustainable and for ecosystem management?
Yeah, I think that's the direction that we're going, is to try to get the students to think about the transition rather than the endpoints. Triggered one. Oh, and one of the questions we've already talked about in class, this is week 4. I mean, it's like this is a really short semester. I think we've got 8 or 9 weeks left. But one of the questions is, how much knowledge should we allow them to take with them? So, and one example is, we know a lot more about human health than we did in 1820. But maybe they want to take the knowledge about human health, but not the whole medical system as it exists with the prolonging of life and the resources. So there are a huge number of questions that the students are kind of sitting there, and they'll think of one, and then they'll think of another. And I think it's going to be a really fun semester. And hopefully, as Bruce ended class yesterday by saying, think of us as the co-shoguns to try to guide this effort to get us through the Tokugawa Society. And the students seem to be getting into it. It was their choice to do this. I think I had a question here.
Yeah, I appreciated your comment about the economic stimulus package going the wrong direction.
Oh, I just said I was observing it. I guess I did say it was the consumerism.
And I guess that's where much of my pessimism lies, is that that's our machinery. We talk about, economy, and it seems like we tune out other things. It's such a entrenched system that it's hard for me to be hopeful sometimes.
That's when the wise men, and we'll get ourselves into a funk, and we just keep saying, well, if we do nothing, we're guaranteed the worst outcome. There are a lot of depressing scenarios.
Well, steady state economy, that's a concept.
Pardon?
The steady state economy is a growing concept. It's starting to make its way into economics programs.
Yes, this is probably a provocative question, but I'll ask it anyway. In your introduction, you did mention the 2 islands, so Ethiopia and Japan, and how they were sustainable in a given time period. And they were probably following principles 1 and 2 to a greater extent, and probably principles 3 and 4 were not part of their mix of how they achieve sustainability within those systems. Now, assuming that there is a historical lesson here, what is to prevent, say, a group of people on planet Earth asserting their privileges and their power to take over the resources and to basically obliterate everything else so that they can become sustainable within this? So principles 3 and 4 may not be necessary to achieve sustainability. They may be desirable, but they're certainly not necessarily part of the mix of the solution. It could be an alternative. Principles 1 and 2, I think, would be much more important for any group of people designing sustainable solutions. 3 and 4 may or may not be, depending on where they go. That is one thing. And then in your talk, I think the assumption, at least implicit assumption, seems to be that we've already reached our limits, the frontiers into which we can expand. And I'm not sure if, Antarctica is still open to inhabitation, or if the oceans can be. So, or like somebody was talking about building high rises so that you can continue to pack more people in a given thing while achieving, the better utilization of resources and so on. So isn't there an implicit assumption that we have somehow reached those critical limits of, this frontier space that's available on planet Earth?
Yeah. There's a number of ways you can look at that. One is to look at what part of the net primary productivity humans are using and ask how much we can go. There are estimates that go up, I think, as high as 21 or 24 billion people for the capacity of planet Earth. Now, it's not clear that one would want to live on Earth that was like that. I think, principle 3 4 probably just makes good sense because people respond to incentives. 3, probably in the context of acting humanely, is the way you'd like to teach, that you should go toward equity rather than the brutal dictator. But in fact, the examples, and we had I was on a trip to Madagascar for 2 weeks, and we had a talk by Craig, I can't remember, he's an ecologist, but he talked about 4 examples of parks that were set up to protect endangered species and how they failed. And one of the very clear messages is that unless you have political stability, you can't have sustainability or protect these. So, I think you could argue a benevolent dictator, a brutal dictator. There's a number of ways. That one would certainly violate Principle 3. But I think the times when there have been periods of sustainability have been more like Principle 3 than like democracies. And one discussion we'll probably have with our students is whether democracy is a form of government that can get you toward sensible. And we had a performance here. I don't know if any of you saw a performance called Sea Change in the Cranach Theatre a couple of weeks ago. They were friends I brought here. And Roger Payne is an oceanographer who discovered vocalization in whales, and he's very concerned about the state of the oceans. And he feels that without population control, there's no hope, even if you go to a vegan diet, because humans we will expand. And he advocates voluntary, make population control available but not forced, and educate the women. But the other thing he said, which we got us all into a discussion about whether democracy worked at all, was that everybody could put $20. I don't know if you were there the night, because I don't remember his argument in detail, but everybody puts $20 in a pot, and this pot goes to the politician who has the agenda of those who contribute to $20 and want sustainability, and they get elected somehow. But the discussion that we got into later is, well, isn't that already admitting that democracy doesn't work if you have to reinvent a way around the current system? And I haven't been able to get Roger to ask him, but I'm an affiliate of IG, Institute for Government and IGPA, Policy Analysis, Public Affairs. And I've asked a number of those people about whether democracy was the best, going to work, and they just say, well, it's not perfect, but it's the best we've got. And I'm out of my depth at that point in political discussions.